and 1.
All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience, so if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use the question and answer tab on your interface and submit your question, and we will try to get to as many as we can near the end of today's webinar. We also have a very interactive chat feature, so I do encourage you, if you have a question, comment, suggestion, whatever for our speakers or for us, please use that public chat, and we'd love to chat you up, and we might even chat you back. And we are doing a drawing at the end of today's webinar for 4 $25 Amazon gift cards, so please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Accelerate Your Serverless Journey with Splunk and AWS. Our speakers today are Amit Sharma, who is the Director of Product Marketing at Splunk, and Ashneet Gujral, who is the Solutions Architect at AWS. Amit, Ashneet, thank you both for joining me today. I don't see you on camera, but hoping you could join me there. There you are. Okay, great. Amit, you are going to be kicking off the conversation, I know, and it's going to be a good one. So I'm going to take myself off camera, put myself on mute, and let you get right to your presentation.
Sounds good. Thank you, Charlene. Hello, everybody. Welcome again. Welcome to the webinar, Accelerate Your Serverless Journey with Splunk and AWS. My name is Amit Sharma. Let me go back. I do product marketing at Splunk. And previous to this role at Splunk, I was part of SignalFX team in the same role. SignalFX is the real-time cloud monitoring company that Splunk acquired in 2019, almost 2 years to date. And before that, I was at AppDynamics. So I have been in this monitoring and observability space for some time now, but the majority of my career has been as a software engineer, engineering management positions in different companies. We want to keep our conversation going after this webinar, so please feel free to reach out on Twitter. Ashneet, do you want to say a few words?
Sure, thanks, Amit. Hello, everyone. My name is Ashneet Gujral, as Amit stated, and I'm a public sector solutions architect at AWS, supporting Splunk. And I have quite a bit of a wide variety of backgrounds. I've been in the app dev engineering space for quite some time, and recently I've kind of come in love with serverless. So that's kind of where I'm going to be focusing on. So with that said, Amit, you want to kind of share the agenda, and then we'll get started.
Yeah. All right, so let's get started. So we are going to talk about serverless journey, why customers are adopting serverless at the first place, why are they choosing serverless first strategy, what are some of the operational challenges and concerns as you adopt or modernize to serverless. We will talk about Lambda extensions in quite a bit of detail, and how do you monitor the performance and optimize performance for your serverless functions, AWS Lambda in particular, using Splunk. We will have a live demo, and we will have ample time towards the end of this webinar for live Q&A. So with that, Ashneet, I will hand it over to you.
All right, perfect. All right, thank you, Amit. All right, so let's talk about serverless, and what are customers looking forward to when they talk about driving success. They really want to go to market fast. They want to reduce cost of ownership and be able to scale at a large level, and of course, be secure. Those are some critical items. You can achieve those, well, most of them through traditional methods, like in the past that has been done. With serverless, these items are just go on steroids, right? So if you go to next slide, we kind of did like a market research here, and we asked CIOs, what's your biggest challenge and what's going on? And they basically said, about 80% of the developer's time is really spent on operation and maintaining the application, and 20% is actually done on innovation. And that's kind of where the biggest challenge is. Like in current state, the way everybody does application development, if they're not in serverless space, the application developers are kind of dealing with all the overhead of running and maintaining the application, but also kind of dealing with all the overheads come with managing the infrastructure as well. If anybody have done a lot of app development, whether using Nginx, Apache, and all that, it's always a headache trying to figure out why the headers are not passing to the applications, what's going on, whereas it's kind of the server configuration problem, less so of an application problem. So that's where serverless comes into here, where you take off that burden and you focus primarily on the innovation. So if you go on to the next slide, let's take out a few things here. So this is kind of this slide kind of talks about the adoption and growing of the serverless in itself. So serverless has been growing for quite some time, and there's hundreds of thousands of customers at AWS that are using it. And as I said, trillions of Lambda execution happening per month. The numbers are extremely astronomical, and they're growing by the thousands in terms of customers, as well as from a Lambda execution point of view, and it's designed to scale. And if we go into the next slide, we talk about serverless in itself. And most people, when they think about serverless, they think of it as it's just a compute layer. Well, that is partially correct, but it's actually a lot more. The technology has evolved, and it's a continuously evolving space where, yes, you have the compute layer, which is kind of the Lambda and the Fargate space, but then you also have the data layer, including S3 and Aurora, which is a relational database, as well as a lot of different integration layers, such as API gateways, SQS, SNS, and so on. So all of those fit into the serverless space, and it's not just focused around compute, it's actually driving business functions as well in some of these cases, as well as helping you develop the core functions. So if you go on to the next slide, you talk about what is a compute operational model. A lot of people look at lambdas, the EC2s, and all that. This kind of diagram kind of depicts you where on the scale of serverless it is. Of course, at the very bottom is your EC2 infrastructure. While not serverless, it is highly scalable infrastructure that kind of is managed by AWS, but you're still required to manage everything on top of it. Then you move on into the ECS, EKS, which is your containerized role, where once again, it simplifies the environment, but you still have quite a bit of things to manage. And then you start to get more and more serverless with Fargate and Lambda, where you are even dealing less and less with the underlying operating system and the infrastructure, or even the core core management plane as well. So you're mainly focusing primarily on the application code. So that's kind of where the serverless operation model is. And as the technology evolves, as things improve and change, I suspect the things will change where customers will only have to focus on the application code and less so on anything else. So going on to the next slide, what are some of the strategies when it comes to adopting serverless? And really, on a high level, this kind of we'll talk about in a lot more detail is when you talk about migration in general, we talk about let's retire the current state of things, so let's move things to SaaS. Right, so that's kind of the space we are at. Then you have the migrate, where you're actually doing the lift and shift of your existing application, and of course, the last part is the modernization, when you're actually replatforming, refactoring, and to take advantage of the newer and greater technologies. So when we look at where customers are, legacy customers who have a lot of applications, they are either forced into the migration phase, and then once they have migrated, they are looking at more modernizing their existing applications. But then you also have new application builds, new customers, greenfield customers who are ditching everything historic and going straight to serverless. So with that said, let's take a next slide about talking about new application building and how that works. And one main question that everybody asks is, what are we building? And this is a very common question. And some of the things that customers are building are anywhere from underlying automation of the system behind the scenes to data processing to web applications to even machine learning models that are coming into the serverless space. And that's kind of very unique because in the past, everybody thinks serverless can only do finite amount of things. Now it's at a point where it can do almost anything that traditional application can do. There are some gotchas here, but it's still evolving technology, and it's getting to a point where you can do anything you want, and just the sky's the limit from that perspective. So next slide, how does serverless work? So serverless is much closer to the microservices architecture where you're talking about small pieces of code. You're not building monolithic applications. You're not building big solutions from the get-go. You're building smaller portions of the code, smaller portions of the applications or solution, and you're tying them together and getting them to work together to actually communicate and get you the response. So if you go to the next slide, and how that's done is all through events. Events are basically your tissues, as per the comment here, and kind of a foundation for serverless, where that's how all the communication between the different events and activities are happening. So to showcase that, you're really driven by an event-driven architecture, which is focused on reliability and scalability. With serverless, which I'll go into a little bit later, you have options like event routers. How do you route your requests? How do you, based on the activity that's happening, how do you route that through the platform, as well as asynchronous events, and of course, event store to be able to kind of perform different business logic in a kind of a eventful manner. So those are kind of the very high level pattern on how serverless kind of has evolved and tie into. So going into the next slide, by doing an event-driven architecture, you're actually decoupling yourself from different states and servers, which is really important because you want to be able to scale. And a lot of the time, organizations struggle to scale because their applications are designed to be very stateful, so that they need to know what infrastructure it's running on or tie themselves to the infrastructure. With serverless, that kind of eliminates that. And one way that's done is, if you go to the next slide, is through essentially step functions. And what it really helps you do is really orchestrate a lot of complex logic. You don't have to build this logic, all of it in your application. You can actually kind of just drag and drop and kind of tie in the different Lambda functions, different services that AWS provide into this step function workflow, and kind of make your application work. And you can add in logic, failure logic, or a event-driven logic throughout your application that kind of drives how the application will behave and how it will respond to different events. So moving on to the next slide, where we're going to kind of focus a lot more on the replatforming your application. And when we look at that, quite a few options are available, but the two that I'm going to focus on is AWS Lambda Container Image Support. This was released, I believe, around last year or so, where now not only you are able to kind of deploy container images in the Fargate environment, but you're also able to deploy it in Lambda. So they can be deployed as a Lambda and can be called through as if it's another Lambda function. Really beneficial to customers that don't want to have a constantly running application that's kind of costing you a lot of funds just because it needs to run, but it's not really being used a lot, or it's very small scale. That could be just portion of the Lambda runtime. And you don't want to spend the time to kind of refactor, remake this image into a Lambda function. So this is very helpful there. And of course, with Lambda, it integrates with almost all our AWS services, which kind of makes things a lot more simple. And it's kind of a pay for use kind of billing model, which is really helpful because you don't have to kind of pay for anything that's running all the time. And the next portion, which is on the next slide, talks about Lambda Extension, which is really, really critical. And this was released last year, where now developers can really focus on their core applications, and they can use extensions to kind of plug in observability model, which Amit will go into a little bit later as well, a lot more deeper than I will. But really it's important because now you can, the core function of your application can remain cleaner and focus on the application, and the extension can kind of handle all the ancillary activities that sometimes it's annoying to the developers to do and to manage. So that's pretty cool from that perspective. So moving on to the next slide, we have, we're talking about refactoring. And if you look at the traditional architecture, which is on the next slide, you have kind of the three-tier application architecture, which is the web servers, the application servers, and the database servers, which is all great, but how do you translate that to into serverless? And that's always a challenge. Well, it's not as difficult as people think it is. So if you go into the next slide, you will see kind of a conceptual model of what a three-tier application looks like. You no longer have the quote unquote the web servers, the application logic, and so on. It's kind of split into really presentation, business logic, and data, and you are not really dealing with managing the core underlying infrastructure. You're really dealing with your application codes, any kind of event and business logic, as well as how you're going to store your data and where that data is coming from. And a lot of that data can also be made into serverless. And to tie everything together, it's all done through APIs, which is amazing because you're able to kind of integrate quite a bit together, and all your requests are coming in through APIs, and responses are done that way as well. So having said that, with serverless, our focus is speed, simplicity, and deliver. We don't want to overcomplicate things. We want to make things simpler and easy to use. And that's why it's really important to kind of take advantage of serverless and how it functions. And going on to the next slide, we'll talk about a little bit of the adoption pattern. Well, most organizations start probably on the left-hand side of this diagram, where they're just using Lambda to do basic processing, things like log processing. They're getting logs from one, they're doing some activities with the log and kind of moving things along, or just using Lambda to trigger some sort of event here and there, nothing critical. Eventually, it gets to a point where you're focusing more on the data transformation, and that's kind of where the Lambda becomes mission critical. Excuse me, and it's getting used in production workloads where you're actually using it for core function of your applications and your day-to-day business. And eventually you become true microservices where to a point where your whole application is a serverless application. You're not really managing infrastructure and things like that. Some things to keep in mind, the considerations on the screen. It is designed to be rapid development. It's meant to kind of reduce time to market. It does require some organizational changes and mindset. And of course, it's a long-term commitment. You can't just start off and drop the idea and then kind of say, hey, I don't want to do this, or come back later. So you want to stick to it for it to become a true realization of your investment. And the last portion I want to talk about is serverless is all about innovation. So you're talking about, as I said, increasing agility. You want to be able to deliver performance, be able to kind of deliver it in a very cost-effective manner, and be able to tie into all kind of services, which is where serverless comes and kind of delivers. Because a lot of the times, to be able to provide the performance and provide the value, you have to deploy hundreds of thousands of dollars of infrastructure to be able to deliver at scale. At that point, you don't have to worry about that. It's based purely on use. It will scale up horizontally as needed. And you can kind of control how it scales by a click of a button. Having said that, that kind of covers kind of a brief about serverless, how it ties into it. I'm going to pass it on to Amit to kind of talk about serverless more in detail and how it will kind of tie into Splunk.
All right, thank you, Ashneet. So let's talk about operating serverless functions. What are the differences as compared to running your code in VMs or bare metal servers? What are some of the challenges that you might face when you are running serverless applications, and how to go about doing monitoring and observability in serverless environment? So to recap, what is the evolution of computing? Basically, serverless function is running on a computer, right, somewhere on the cloud, on AWS side. But where did we come from, right? What's the computing evolution? So we started with physical machines, right? So physical machines requires us to guess the planning, the capacity. It lives for years on premises. It has heavy investment, CapEx. The cycle is slower, so low innovation factor, and deploy in months. The code deployment frequency used to be 6 months or more, a couple of times a year. Then we went into virtual machines. And virtual machines gives us hardware independence. You can run many operating systems on that particular hardware. You have faster provisioning speed, minutes, hours. You could use, if you're running virtual machines in the cloud, for CapEx, trade CapEx for OpEx. It can provide more scale because then you can bin pack with virtual machines. You can run multiple virtual machines in a computer. It is elastic, and it provides the speed and agility. So then we saw a few years ago the amazing paradigm shift from virtual machines to containers, or containers running within virtual machines. Containers are portable, provide us portability, so it provides platform independence. Consistent runtime environment, a container will run just the same as it is running on Linux, or as it is running on-premises or on AWS. Higher resource utilization, that's a big one, right? So because we are doing bin packing, we are running multiple containers within the same compute environment. It gives us isolation by Linux and Docker and container environments provides us isolations. And the startup speed is seconds as compared to hours or months with different previous generations. Now we are evolving into serverless. Now serverless could be Lambda functions, or it could be Fargate. Fargate will let you run your tasks in ECS or containers within EKS environment. So these environments will give us total independence from infrastructure management. It provides us continuous scalability. You pay for the usage. It's pretty much comes close to what you are paying for what you're using. And there is no zero maintenance. There's complete abstraction from the infrastructure. And that is why Gartner predicts, or Gartner estimates, that 75% of organizations are using or planning to use serverless functions in next 2 years. And these are the reasons why they are using. Now, if that is true, right, serverless provides us all these benefits, then why is not every single use case, every single workload on serverless? And why is not every single organization adopting serverless? Well, there are some challenges in serverless operations. Lambda enables us to increase the pace of innovation, control costs, but it also presents some monitoring and observability challenges. The first one is agent-based approach no longer works. Since serverless separates code from infrastructure running it, agents cannot be installed to collect and transmit observability data as we were doing on our virtual machine-based or Kubernetes-based or container or bare metal server-based applications. Now, let me put a rider on the second one. Unless you are using Lambda Extension, if you're using the serverless function, or if you're using serverless anywhere else but AWS, there is no place to batch the data. Lambda Extension provides that. Splunk Lambda Extension has some buffering capabilities. I'm going to talk about that in a minute. But if you're not using Lambda Extensions, traditional monitoring tools that use batch and query architecture do not work in serverless environments, as they are not designed for streaming data analytics. Using them in serverless will result in dropped data points. And because of that, the results that you're seeing, the analytics that you're seeing, will be incorrect. And finally, scraping metrics from cloud APIs will result in slow insights. So serverless run for milliseconds. Right? You are built for milliseconds. They run in seconds. Cloud APIs typically give you insights in minutes, 5 minutes, 10 minutes interval. So these are the challenges with serverless. And how do we solve that? So I want to introduce Splunk Infrastructure Monitoring. Splunk Infrastructure Monitoring is the real-time streaming metrics platform that provides visibility and insights into your performance of your cloud infrastructure, Linux, Windows, vSphere on-premises infrastructure, as well as AWS infrastructure, as well as all the AWS services. It is purpose-built for ephemeral and dynamic environments such as containers, Kubernetes, serverless. It not only looks at, gives performance insights about your Kubernetes and containers that are running in Kubernetes, but also automatically discovers the services that you're running within these environments. Things like technologies that you use every day, right? Like Redis or Kafka or Cassandra and MongoDB, Nginx, or hundreds more, right? So we provide automatic discovery of about 200 of these integrations. Accurate alerting is a big feature differentiator from the other monitoring products that are available in the market. So you not only get fast, but also accurate alert. And as I mentioned, we have 200 integrations in addition to the infrastructure services that it provides visibility into. Coming back to Lambda, and how would we use Splunk infrastructure monitoring to get visibility into performance characteristics of Lambda functions? So Lambda Extensions. So as Ashneet said, it was announced last year, and Splunk has a Lambda extension for AWS Lambda. It provides real-time AWS Lambda monitoring. It enables DevOps teams to easily understand the performance, usage, bottleneck across the entirety of applications. So as I mentioned in the previous slide, Splunk infrastructure monitoring provides visibility not only in the serverless applications, but also your entire cloud stack. So Ashneet was mentioning Lambda. Using Lambda, you can access 140 of AWS services. So typically, you would have not only just the serverless functions, but also you will be consuming some managed applications, or you might be consuming some your own custom applications that you're deploying on EC2 or on EKS. So Splunk infrastructure monitoring can provide you all that visibility from one single place. Whether your applications consist of 100% serverless or a mix of serverless or a traditional apps, you can monitor the entire cloud stack in real time. So let's dig deep into Lambda extensions. So extensions extend Lambda invocation cycle to only run when there is something to do, and do not run when there is something not to do. Right? They can also continue to run after a function invocation has finished and send the telemetry data out about what happened during that invocation. They can initialize the work before the server execution starts. But there are external extensions and internal extensions. The external extensions run as an independent process. It is separate from the runtime within the execution environment. You can see the process boundaries here. It can start before the runtime process and continues to run after the function invoke is fully processed. Because external extensions run as their own processes, you can write them in a different language than the language that you're writing your function in. And it is best done as a self-contained compiled library. Now, this is big because you may choose to write your applications in any supported runtime: Java, .NET, Node, Python, Go. Splunk wrote our serverless extension for Splunk extension for AWS Lambda, and that can work for any environment that you're running. So let's talk about resources and security. This extension that I'm talking about, Splunk extension for AWS Lambda, what are the implications of running Lambda extensions? As extensions run in the same execution environment as the Lambda functions are going to run, they will share the resources with functions such as CPU, memory, and the temp disk storage. Extensions also need to be compatible with the associated operating system. In addition, extensions share the same IAM role and security context as the function does. So the extension has the access to everything that your function has access to. And if the extension needs access to something else, this must be included in the function IAM role. You can, and Splunk extension for AWS Lambda does not need any other privileges or access. Now, how do we package extensions? It can be packaged, as Ashneet was mentioning. You can run functions as a container image. You can build image functions. You can include extensions within the container image. So I'm going to move on to performance, because extension is running within the execution environment of the function. So let's see what performance implications it may have on serverless or Lambda function performance. It can impact the performance because they are using the same resources, CPU, memory, storage. If an extension performs compute-intensive operation, you may see your function execution duration increase. As extensions initialize before the runtime process starts, they must finish initializing before Lambda invokes the function. And that can also increase the latency. You can, now how do you, if there's more latency, if more resources needed, then you can increase memory for the function in the configuration, which will also proportionately add CPU and network throughput. And during the function, and all extensions must complete, right, using the configured timeout setting, or your function will timeout. So with that, let's move on to, we have our serverless functions deployed. We have extensions to monitor that. You may want to write other extensions to do something else to your serverless functions. Now, what to monitor? What are the performance characteristics that we monitor? So when we invoke a Lambda function, the request is processed in a container environment, the execution environment. And when a function has not been executed for some time, or when you need to process more concurrent requests, AWS Lambda will start a new execution environment. The initialization of the runtime and your codes leads to this latency. This latency, as you might know, is called cold start. If you have several Lambda functions, like one function after another function invoked in a chain, these latency will add up. This will not only result in the poor user experience on your application, but since it is AWS is billing based on the duration up to the nearest millisecond, there are cost implications as well. And latency, so Akamai did this survey, and they found like for every 100 millisecond increase in website load time, the conversion is decreased by 7%. So as operators and developers, we have to maintain the latency as low as possible. And cost also, we have to optimize. So basically, we need real-time visibility into latency so that we can optimize how our resources are consumed. So cold start is a big one. Then duration. Again, we are billed based on the milliseconds on duration. Throttles. It can be because of cold start or the limits on the concurrent execution. It can also be because of your APIs. So what API gateway, or what happens before the Lambda function is getting executed. So throttling. Concurrency. So how many functions can be executed in parallel? So you need visibility into concurrency. There are two types of concurrency: reserve concurrency and provision concurrency. Reserve concurrency is however many instances of Lambda execution environment functions that can be executed in parallel per account in AWS. So that's fixed. What you could do is you can assign reserve concurrency for a particular function. So you are not charged for reserve concurrency. You may want to do that if you want, if there is a new load coming, a lot of load is coming on your application. For example, it is going to a queuing mechanism, for example, SQS. and your function is doing an update to a DynamoDB, you don't want to throw all that load to DynamoDB concurrently. So this can be an architectural decision that you can make that, hey, I'm going to do reserve concurrency, so I'm going to only allow 100 such invocation in parallel, and everything else will be queued up. So my DynamoDB will have a better performance. Provision concurrency, on the other hand, is where you would add concurrency so that you will reduce cold starts. So there is no or little initialization time, and your end user experience is flawless. You definitely want to see how many invocations are happening and errors. Errors can be because of Lambda environment, the execution environment, or it could be because of your code throwing an exception. So, and we can use a Splunk infrastructure monitoring to monitor all those performance characteristics. So let's take a look at how do we get data in. So there are, we talked about ad nauseam about Splunk extension for AWS Lambda. It has two modes of getting data in. It has fast ingest and buffering. And the buffering is what I was talking about, the batching earlier. Fast ingest you want for the functions that are infrequently used. And that will get the metrics data into Splunk infrastructure monitoring the fastest way. For the applications where you do not care about getting data as soon as possible, you could use the buffering mode. Now, we looked at a couple of performance characteristics like invocations, throttle, cold starts. That will be provided by extension, but there are certain things like provision concurrency, spillover of provision concurrency, that will not be provided by Lambda extension. That is coming from CloudWatch. And for that, you could use CloudWatch MetricStream, because MetricStream provides observability telemetry data to Splunk infrastructure monitoring in near real time. And we are going to take a look at that as well. Now, what about business metrics? What about things like orders processed per invocation, if you want to see that? So for that, we have Lambda wrappers that you can use as a Lambda layer in your function, and then you have you can send all the metrics data with all the dimensions that you want to add. So you have a metric name, metric value. You can add dimensions, so you can analyze this data, which is relevant to your. It is not operational telemetry data. It is about your business. So you can analyze that data later. Now, I want to talk about why Splunk, because this is available. Serverless monitoring or monitoring, metrics-based monitoring are, there are other solutions available as well. And this is what the traditional batch metrics architecture does. So traditional approach to monitoring will not work in the serverless environment. Traditional tools, they will typically store metrics data into time series database. And they have separate system for alerting, visualization, automation, and data science, machine learning jobs that they are running. All these components that you are seeing on your right-hand side, they will periodically poll the time series database or TSDB and update their state. That's batch inquiry. So I'm going to poll this TSDB every minute, every 5 minutes, every 2 minutes, and I'm going to update all these systems that I have on the right-hand side. This architecture does not scale. It's not fast enough in cloud or serverless environment. Now, specifically for serverless environment where they live for milliseconds or seconds or minutes, it's not long-running processes. This approach does not work. We take separate approach. The Splunk infrastructure monitoring architecture is optimized for real-time behavior. Now, first, why? Why do we do that? So ultimately, monitoring is not just putting up pretty charts or dashboards on a TV. monitoring is putting yourself in a position to anticipate problems. And that is specifically true for cloud and serverless and Kubernetes and continuous environment. Now, how do we do that? So to read this slide, is look at from left to right. First, the data is coming in. It is coming in from our open telemetry collector that you can deploy in Kubernetes, or CloudWatch MetricStream from serverless environment, or Lambda extensions. Now, at the beginning, at the gate, we separate the metadata from the metric data value so that we can scale these two systems separately. And our analytics, you can analyze on all the metadata that is coming into the system. Second, as the data is coming in, we are automatically doing rollups. So 1 minute, 5 minute, hour rollups is done as the data is coming in. And third, data points is then streamed to the components that you're looking on the right-hand side. So interactive visualization. This is not batch and query. This is not happening periodically querying the TSDB. The data points are then streamed to the jobs that they need data. That can be your visualization, alerts, data feeds, your automation jobs that you have put. So your dashboard will refresh, your alerts will fire, your automation task will trigger within seconds of the data coming in. So that's the fundamental difference between Splunk infrastructure monitoring and competitive or other solutions available for cloud native monitoring. So let's take a look at the product in action. So let me go here and look at the demo that I have set up. So first of all, what I have set up is this serverless workshop that AWS runs, Innovator Island. And the reason why I have set it up is because it not only uses Lambda functions, but it is also using other AWS services like DynamoDB, SNS, ELB, and others. So let's talk about Lambda Extension and how I'm getting the telemetry data into Splunk infrastructure monitoring. So we talked about, let me increase the size a little bit. We talked about how do you get data in. There are two modes, fast ingest, buffering. Fast ingest you want to use for rarely used or infrequently called functions. And buffering is where you do not really care about data coming into Splunk as soon as possible or within seconds. Now, how do I install? So there are two ways to do this. So first is what we have been talking about, putting your serverless function within a container image and then taking that container image and putting that in ECR and using that for your serverless. So that's the recommended approach for production workloads. So you can embed or you can add this this container layer into your serverless function container image. So you can get the layer from this is published from this ARN, and you can add it to your container image. And this is how you would do it. And AWS has many other examples where how to build container image for your serverless functions. And whatever you want to execute in that, you can add to that container image. Alternatively, what you could do is for dev test, if you want to just start testing this out, you're playing with it for the first time, you can add these extensions as a Lambda layer. So you can upload your code in a zip archive file to AWS Lambda, and then you can add these two layers I'm running here. And again, let me increase the size. Lambda extension as well as the wrapper. Oops, wrong click. Lambda extension and the wrapper are available as Lambda layers. So you can use that in your functions. So now let's take a look at this particular setup that I have done. So I have already done Innovator Island, which is sending data to my Splunk infrastructure monitoring. Splunk Observability Cloud includes Splunk infrastructure monitoring. So let's just focus on infrastructure tab. So I have two Lambda functions, which are as part of my Innovator Island workshop. So I'm looking at number of invocations by AWS account. I'm using only one account, deployed in only one region, US West 2. And number of invocations. Was there any error? Was there any throttle? So I'm looking at those. So this is the latency, right? The average duration on which I'm built. So all this information, all this visibility is available just by adding that Lambda layer to your container image or to your serverless function. So moving on to more realistic example, this is our demo environment. So in production, you would have many more Lambda functions. So by the way, I talked about Splunk infrastructure monitoring. It provides visibility into not only the serverless function, a lot of AWS services that we have deployed here in our demo environment. So EC2 instances, there's a whole bunch of, like almost 4,500 EC2 instances running. And then you are looking at the navigator, which gives you out-of-the-box picture how my overall deployment working. It will give you overall how my CPU, disk, network utilization across my AWS accounts and in different regions. It's the entirety of your AWS deployment. You can easily group or see how these EC2 instances are working in my different availability zone. And you saw that it happens like within 1 second. That is because of our real-time streaming architecture. You can also do outliers. So all these yellow things that are happening, you can check whether they are indeed an outlier or not. So it was warnings, but now all those things are gone. So they are operating at a higher CPU utilization, but it is not. This is per historical baseline, so it is not an anomaly. So coming back to serverless functions, we have many more Lambda functions deployed here. This will be more representative of your production environment. So we have many Lambda functions in different languages, different runtime. You can group Lambda functions by account, memory, what you have configured. You have region or runtime. So many dimensions that you have configured these Lambda functions. You can group them. Now, this is the overall bird's eye view of how your serverless architecture deployments are performing. So you have number of active functions that are sending data. You can a couple of AWS accounts, different AWS regions, total invocations that are happening in the last 5 minutes. And again, you can customize any of these charts. Invocation errors or throttles that are happening. So total errors that are happened across all these functions, 188, and then you have a heat map that you can then dig deeper into that particular serverless function. You have average duration of all functions, and then you can get into this particular function, which is average duration is 3.13 minutes. It may be designed for higher duration because it might be doing a lot of work. Throttle again is looking at the cold starts and how many requests are being throttled, and concurrency and provision concurrency. So we talked about, so this is all data that we are getting from Lambda extensions. There are other data like provision concurrency we are getting from MetricStream. So MetricStream provides near real-time visibility from CloudWatch metrics to Splunk. So it is basically connecting CloudWatch metrics will be deposited through our data fire hose, and that is a low latency observability. And how do you set it up? There is a cloud formation template that you can set it up for your region. It is per region, so you will have to set it up if you're in multi-region deployments. You set it up and you tell us that you start using MetricStream rather than the CloudWatch integration. And that's it. So we'll start getting MetricStream data, which will give us provision concurrency and spillover. So provision concurrency will give us how many functions can be executed in parallel, and if some functions that are executed beyond that limit, that's called spillover. So you need to keep that in mind as well to optimize cost. So let's go back to our slides, and that's all the content that I have for today. But we have free training, so you can look at Splunk infrastructure monitoring. You can sign up for a free trial. There are a couple of blogs that are really good on this topic, Lambda Ready certification, as well as Lambda Extensions. I am sharing that GitHub link for Splunk Lambda Extensions, and why you can use Splunk infrastructure monitoring to monitor all of your entirety of cloud stack on AWS. So a data sheet on that. With that, Charlene, are there any questions that we can
Yes, we have gotten a couple questions in, but there's a couple minutes left. If you do have a question for either Amit or Ashneet, go ahead and use the question and answer tab. Get it on in there. We'll see how many we can get through. Let's see, the first question here. Can Splunk monitor and generate alerts on timeouts and or packet drops between processes or even containers speaking to each other?
So that's network monitoring you're referring to. And we have a network performance monitoring product that you can use, I think, for this use case to look at the network communication between two containers. Yeah, so Splunk infrastructure monitoring, you could, if both containers are sending metrics to Splunk infrastructure monitoring from application point of view, you can look at the performance, the network performance of those two infrastructure components. But the performance metrics on the communication between two containers, I think, is you need network performance monitoring product.
Okay. All right. Great. Let's see. Thanks, Luis, for that question there. Next question: does serverless applications make sense for small businesses?
Yeah. So it definitely makes sense for multiple reasons. So one of the reasons is serverless from cost perspective, right? Serverless comes really close to cost on the usage that you are using, right? So it abstracts out entirety of infrastructure. You are paying only for what you are using, how many invocation, what is the duration, and what configurations have you used on serverless functions. So you're not paying for idle resources. The second thing is, since you have abstracted out infrastructure, you are no longer maintaining it. So you don't have to spend your precious resources on maintaining EC2 instances or VMs or Kubernetes cluster. So for sure, it definitely makes sense, irrespective of the size, but especially for small businesses, it makes sense. But do not try to retrofit your existing application into serverless architecture. Rather, look at the framework that Ashneet shared earlier, right? Building new application or modernizing your existing applications. Not every single use case is fit for serverless, but things like event-driven programming, right? So those use cases definitely make sense for small businesses or businesses for any size.
Yep.
All right, great. Go ahead.
Just going to quickly add on to what Amit said was really around it reduces total cost of ownership, especially when it comes to small businesses. They're kind of going into the greenfield area, and serverless at that point is very important and critical to them because, as Amit said, they don't have to own or maintain servers, which really helps speed things up, and they can focus on business at hand rather than dealing with all the operational activities.
All right, great. So we're about 6 minutes to the top of the hour. So I think we have time for one, maybe two more questions. Upender asks, since Lambda uses limited memory, how much resources are estimated for extensions, and is usage consistent across all functions?
Yes. It depends on the extension, right? And what the extension is trying to do. If you're writing, by the way, this is the custom extension that you are writing. Depends on what the extension is doing and how many resources it is consuming. You could configure additional resources as you are configuring your functions. So if you add memory, it will add CPU and network throughput. Splunk interest Lambda extension is negligible. It adds negligible resources to your function usage, especially if you're using the buffering.
All right, great. Let's see if we can squeeze one more question in here. Let's see here. What about logs? How do we get logs from the function to Splunk?
Yeah, great question. So Splunk is the Splunk logs, the Splunk enterprise or Splunk cloud environment. How do you get logs out of your functions? So extension has a log API. So it can get data, log data, events data from your function, from your business logic, as well as from the Lambda environments to your Splunk enterprise or Splunk cloud environments. This webinar, we focused on the metrics-based monitoring. So how to know whether your functions are performing optimally, because it has an impact. All these considerations have impact on your not only the performance, but also the cost. So logs is something separate. We can talk about that in next time. But you could use extensions to pull logs out of your functions and send it to Splunk Cloud, Splunk enterprise environments.
All right, great. So doing a time check, we're about 3 minutes to the top of the hour. So unfortunately, that's all the time that we have for questions. I think we got to everybody's questions, but if we didn't, I do apologize. And please know that the folks at Splunk will be getting a copy of all the questions that came in, and I'm sure they'll be more than happy to follow up with you offline to get your question answered. Now, another quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinars and look in the on-demand section. It should be right there waiting for you. Okay, one last thing before we wrap things up. I did mention at the top of the hour we'd be doing a drawing for 4 $25 Amazon gift cards. So without further ado, the winners today are, let's see, Stan T. Congratulations, Stan. And second winner is Pete T. Congratulations, Pete. Third winner today is Jane C. Congratulations, Jane. And our fourth and final winner today is Juliana K. Congratulations, Juliana. We'll be following up with all 4 of you via email to get your Amazon gift card over to you. So please check your inbox. And if you don't see anything there, please check your spam folder. Amit, Ashneet, thank you both for such a great presentation. So much information in this webinar. Such great stuff. We got a lot of chats from the audience expressing their appreciation as well. So do want to thank you both for your time and your expertise on today's webinar.
Thank you.
Thank you.
All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.